All right, guys, this video, we're actually going to move on. I think it's like the third page in the on this PDF file. We first did on the first page even and odd functions, which talked about symmetry, which can help us get the graph or the big picture of the graph. Um, Another thing that can kind of give us little details of the graph are intercepts, and this should be a review. Now, to find intercepts, you guys can take this down. An x-intercept is we would actually let the opposite variable equal 0, and then we would solve for y. So this is how we could get it algebraically. Now, it kind of makes sense, if I graphed something and I just put a point on the x-axis, let's say that x value is 3. Well, since it's on the x-axis, the y value is 0. All right, and the opposite will happen for a y-intercept. Let's say this is 0, 3. The y-intercept, the x value is 0. So you can see that's what happens here. All right. And we can do this for any function, right? Let the opposite variable equal 0 and then solve for that intercept that you want to find. So if I wanted to do number 1, I know number 1, if I graphed it, would be a line. If I wanted to do the x-intercept, I would let the opposite variable equal 0, which is going to be the y. So I would have 0 equals 3x plus 4. Right? I have a simple linear equation to solve for. When you solve for that x, you're going to get negative 4/3. So that's where it's going to hit the x-axis. Now you could just leave your answer like that, or if you wanted to write it as an ordered pair, well, it's just negative 4/3 and the y value is 0. Okay, the y-intercept, we let the opposite variable, which is x, we let that equal 0. So we would have y equals 3 times, let the x equal 0, and then 3 times 0 plus 4 is 4. So that's the y-intercept. Now you kind of know that because look, this is in slope-intercept form, y equals mx plus b, and b is the y-intercept, which is the 4. So that just matches up right there. Okay, if we slide over to number 2, we would have a quadratic. So kind of do the same thing, x-intercept. So x-intercept is really like finding the zeros. Because you let the y equal 0. So you have 0 equals x squared minus 2x minus 24. And then this quadratic, you would always try to factor it. And this one does factor. It factors to x minus 6 times x plus 4. So here's an example where you could see you're going to get two x-intercepts. You're going to get x to equal 6 and negative 4. And they would correspond to the points 6, 0 and negative 4, 0. Now, let's say you had that and it didn't factor. Then you would have to use quadratic formula to get the x-intercepts. Okay, y-intercept. If we put zeros in for all the x's, you would have 0 squared minus 2 times 0 minus 24. All these would go away, and you'd just be left with negative 24. So that's the y-intercept. Okay, I want to move to number 3. And actually, the last 4, 3, 4, 5, and 6 is kind of a segue. These are fractions. In fact, number 4 we already did with the basic shapes. But we're going to eventually graph ones like 3, 5, and 6, which are rational functions. So if I wanted to find the intercepts, so I'm going to zoom in on 3. If I want to find the x-intercept, if I set y equal to 0, I'm just going to put 0 in for this. All right. If you have a fraction that's set equal to 0, all you are concerned with is the top. Right? I don't want the bottom to equal 0 because that would make the fraction undefined. It wouldn't make it 0. If the top is 0, 0 divided by anything is 0. So all we have to concern ourselves with here is the top. So if I set the top equal to 0, right, I'm going to add 3 divided by 2. This x-intercept is at 3 halves, or 1.5. For the y-intercept, you're going to plug in 0 for x. And what's really going to happen is these kind of go away, and you're just left with this. It's kind of the shortcut of how to do it. You're going to be left with negative 3 over 1. So that y value is negative 3. Right? At the top, you would have 2 times 0 minus 3, which is negative 3. The bottom, you would have 4 times 0 plus 1, which is 1. So negative 3 over 1 is negative 3. Okay, 4, And you know what? I'm going to look at the graph for this. Here's the graph. Right? We did that before. And if you see, yeah, the asymptotes, there's no intercepts at all. There's no x-intercepts. There's no y-intercepts. Now, you're probably not going to graph these right away. So if you were to use this algebraic test, you're going to see what happens. If I let y equal 0, remember kind of piggybacking off of 3, we don't look at the bottom. That makes it undefined. Well, if you look, the top never equals 0. It's always 1. So since these don't equal each other, that kind of proves there's no x-intercept. That numerator can never equal 0. So therefore, there's no x-intercept. Now, when you do y-intercept, you're going to plug in 0 for x. You're going to have 1 over 0. And that's not 0. This is undefined. So that proves that you're not going to get a y-intercept. All right. Okay, I'm just going to skip to 6. Just do one more. For 6, and I don't want to graph that mess right there. So if I just want to find the x-intercept, if I let y equal 0, remember I'm just looking at the top. So we just set the 2x squared minus 8 equal to 0. If we get the x squared by itself, see, you would add 8, but then you would divide by 2. So you would get it to equal, what, 4? And then when you take the square root, we're going to get 2 x-intercepts. We're going to get them to be plus or minus 2. And at the y-intercept, remember I say kind of a shortcut, the y-intercept. If you plug in 0 for all these x's go away. I'm just going to get rid of them. I'm going to scribble them out. Right? They all go away. And this is what you're left with, that negative 8 over 3. So that's the y-intercept, this negative 8 over 3. All right, so you can see we can do these real quick by just plugging in 0 for the opposite variable. This will give us kind of little details of each of these graphs.